What if I stand up? I shouldn't do that. Okay.
No, it's fine. I'll go.
Well, I'll be doing demos most of the time.
No, it's fine. Now you can do whatever you want.
Okay.
Thank you.
Okay. Well, thank you, Philip. So hello everyone. My name is Pete. I work at Broadcom in the Mainframe software division. And can I see a show of hands of how many of you have heard about Broadcom before? Okay, a lot of people. So what do you think Broadcom does? Like, you know, any ideas?
Hardware.
Hardware, yeah. So, yeah. It started with hardware, like mainly networking. So if you have a data center somewhere, or if you're using cloud, it's highly likely that Broadcom Silicon is powering the infrastructure behind the scenes. From the consumer perspective, if you have an iPhone or high-end Android devices, it's most likely you have a Wi-Fi chip from Broadcom. And just a fun fact, the Raspberry Pi CPU is also made by Broadcom. But I'm from the software division. So in 2017, Broadcom placed a bid to acquire Qualcomm, that's making most of the cellular chips. But the acquisition was not approved by the US administration, so the company was left thinking what to do next, and it decided to pivot into software. And it started with an acquisition of CA Technologies in 2017, which I used to work for. We have a large development center here in Prague. A year later, the Symantec's security division was acquired by Broadcom, and last year the acquisition of VMware was announced, and it just completed last week as we speak. So in my group, we're focusing on developers of mainframe applications, and the developer experience. So before, all right, and I'll be talking about VS Code. So VS Code is at the front and center of what we're doing, and that's nicely captured by a tweet by Sean Wang, and I don't know if this is visible on this projector, but he says, what if VS Code was the universal DevTools UI layer? And that's exactly what we think, and where we are taking the assembler and COBOL developers of mainframe applications. And before I go to show you what we built and how we build it and what's inside, let me show you what the typical developer experience of a mainframe developer looks like today. So, we'll go to terminal. Unfortunately, this doesn't support light color scheme, so please be tolerant. And I'll try to make it slightly bigger. All right. So I'm logging into a terminal. So you might be familiar with Unix terminal. This terminal predates Unix. It's called a 3270. It was created in the 60s. And it's still quite it. So I'll log in. And I'm presented with a command line. I can ask about a time, but that's not interesting. I can go into an environment that's made for developers to make us more productive on the mainframe. It's called the Program Development Facility. And it's a panel application. The one thing about this terminal compared to Unix terminal, you may know that the Unix terminal typically has two modes of operation. Either character at a time, where as you're typing, the application that you're talking to is receiving characters immediately, or if you're on a slow line, you can switch to a line mode. When you're typing the whole line, and when you hit enter, the whole line is sent to the program on the other side, and then the response comes back. I mean, we usually are used to the character mode, but if you're working with remote systems on the other side of the earth, sometimes you may find out that the terminal switch into line mode, which gets surprising to a lot of people. This terminal is a screen at a time. So as I type something and I hit a special key or enter, the whole screen is sent, or rather a diff of the screen is sent to the remote system, and then vice versa. So here I can go search for my program into 3.4, and look it up in my data set, which is a predecessor of a file system. So I go in, and I can go edit my program here. And this is an assembler application. It's colored. this terminal, by the way, is called a green screen. So if you see like old spy movies, looking at a terminal and things, that's this terminal. But here we already have like 8 or 16 colors. And there are some comments at the beginning. I can use F keys, F7, F8 to scroll up and down. And here I see the start of my application. So I see I'm being called from the operating system, and I'm linking in a new stack frame onto the stack frame that I received from the operating system. Then I'm branching around an iFeature, and there's the mainline code here that calls some subroutines, that opens some files, does some processing, closes the files, and at the end it unlinks the stack frame that was added at the beginning. So that's a small, simple assembly program. Below there is definition of variables or symbols, as it is called in here. So this is what an experience of developers on Mainframe looks like today. And maybe you'll be surprised how productive the guys are with this. Very productive, really. And it's kind of hard to convince them to try something else. But this generation that's been maintaining these applications for a long time is slowly retiring, and there is a new generation coming in, and all these new guys already know the new things, like VS Code, for example, and they want to use the tools they know, because they can get productive with this, in a year, 2, 5, 10, maybe 20, right? Like the current generation, but they are already productive with the environment they know. So eventually, I expect they will still have to learn bits and pieces of this, but we're working hard to allow them to stay where they are comfortable and use these modern tools. So let me show you what our tooling looks like. So VS Code, probably familiar to everyone. I'll try to zoom in a little bit more. It's kind of hard to read, but we'll see. So the same assembly program here, if I open it, I still have it colored. I can scroll around. I don't have to use F keys. By the way, I'm happy to have that Apple finally got the senses and got rid of the touch bar, because F keys are really important for mainframe developers. Something I didn't show you, but ask me afterwards. I'll show you something after the session. So I have highlighting. I can scroll. Smooth scrolling. That's actually the #1 feature that when we are doing interviews with clients after they adopt this modern solution, we ask them, what's the #1 feature? They all consistently say scroll. I mean, we put in a lot of energy that I'll show you what we do, what this can do. But scrolling is a big thing, because in a terminal you can't easily scroll. You have to go page by page. And, okay, anyway, I'm digressing. So here, I have my coloring. I can look at an instruction. I can hover over it. It tells me, this is a store multiple instruction. It's a machine instruction with a particular format. Has some operands. Doesn't change the condition code. If I want to know the details about the instruction, I can click here. It will open the IBM documentation, because the hardware is from IBM. So the hardware instructions are described in an IBM manual. I can hover over a symbol to see how it's defined. So this is an absolute symbol. Has some attributes. I can right click and can say go to definition. I see that this is just an equate, R15 or 14 to 14. I can go back. I can look around. I can right click and peek at the references to see where everywhere in the code this particular symbol is used. This is a little small, so we don't see it, but yeah. All the standard things you expect from a modern editor. I can start typing. I get an auto completion. Okay. Right. If I make a typo, the editor immediately tells me. So all the things you expect from a modern editor, we build it in. Now, let me look at my notes before I go on. Are there any questions about this?
So how long have you been developing this?
That's a good question. I don't know exactly. It started as a project of interns from the Faculty of Mathematics and Physics, working under the supervision of one of my colleagues, and I think might be about 5 years now.
I have another question. Do they plan to like retire the mainframes anytime soon?
Well, who? right. So yeah. So maybe I'll answer first. So the what we might call it, me being in the mainframe business, the bad guys have been talking about retiring mainframe, ever since they could. There was actually an article in PC Magazine, I think, by one of the editors, Stuart Alsop was his name, and he predicted a particular date that when the last mainframe would be unplugged, right? And it's been like 20 years ago when the date was that he predicted, and then later IBM did an interview with him and did a picture with him eating his own words, So no, the mainframes are not going anywhere. I mean, it's a small industry in terms of people, but it still powers all of the economy, and the majority of the business data is still on the mainframes. And with all the cloud and everything, that's just adding to it. But the business critical applications of most large companies still reside in the mainframe. Yeah.
Thank you.
Pavel had a question.
Yeah, my question is, do you run some assembler or any other kind of language server in background? If so,
Yes. Great question. Great question.
Will be this language server open source or it's open source?
Great questions. Thank you. And this is a great segue to the next section. So how is this implemented, right? So this is a VS Code extension. It's called the HLASM because language support, because HLASM stands for a high level assembler, which is the name of the assembler on mainframe. It's called high level because it has a macro language. It's not like Intel. It's more user friendly. It comes from the 60s originally. So in the 60s, people used to write assembler, right? Today's CPUs are not meant. Today's instruction sets are not meant to be written by humans. They are meant to be created by compilers. But in the 60s, people were actually writing this assembler. So it's way more human friendly than x86 assembler, for example. So that's the name of the extension. It is open source, so you can look it up. It's okay. I won't spill more beans because I'll get to it in the presentation. So, all right. So you probably know VS Code. VS Code is an Electron app. So if I go in, I can toggle the developer tools. You won't see much over here, but I can click here. And you can see the DOM, right? All of this. So it has the UI is actually Chromium, and there is a Node.js process. So all of VS Code editors and everything is running in a browser essentially, and there is a background process that's associated with it, and that can be seen by opening Process Explorer. And here you can see our language server running. So let me see if I can make it bigger. Yeah, so you see I'm on a Mac, so I've got a Darwin language server. So this is our language server, and that's a nice segue to another thing, which is this extension host. So the extensions in Visual Studio Code always run inside of an extension host, and that's a significant and probably the most important design decision the VS Code team made at the very beginning, because they didn't want extensions to interfere with the UI, and that's one of the reasons why VS Code's UI and editor is always quick to respond, and extensions cannot slow it down or kill it. Unlike with Eclipse, where a bad behaving extension can do just about anything, even block the UI thread, which makes the experience with Eclipse not so good. So, any questions here before we move on? All right, so now I'd like to go back a little bit to the origins of VS Code. We talked about the first design decisions the guys the guys made. So does anybody know how VS Code got started, or maybe what was the name of the project originally, and where it comes from?
Originally there was Atom.
There was Atom at the time, yeah, okay.
They,
That was very
they
popular.
started that completely from scratch, as far as I know. Like
Yes.
Microsoft.
Yeah, so we, yeah, any other guesses before I start
I
talking?
think it was internal project at Microsoft.
Uh-huh.
Some interns have started it, and later on we saw a future for it, and we open source it, something like that.
Partially, yeah, it started, yeah. Anybody else, any tips?
I
Tom?
think that there is editor, front-end editor API which is used as the goal for the.
Yeah, do you know the name? Do you know the name?
I
Do you
don't
know the name of the
remember the
project?
name, but.
Yeah, that's a good clue. It's called Monaco. Monaco is the editor inside of VS Code, and that was how the project was originally named at Microsoft. It was called Project Monaco, and it started with a famous Swiss computer scientist in Zurich, whose name is Eric Gama. So can I see show of hands who heard about Eric Gama before? Yes, good. All right, I'm sure you've heard about him indirectly at the very least. So
Game of Four?
sorry.
This is from the Game of Four.
Yes.
Yeah, of course.
Very good, very good. So Eric Gama is one of the 4 authors of the highly influential design patterns book. So if you've heard about design patterns, you've heard about Eric Gama indirectly. And he was working for IBM at Eclipse, and Microsoft has tried to get him on their side for a long time. And around 2010, he was not happy with where IBM was taking Eclipse, so he started to talk to them, and they were discussing what would be a project of interest for both parties, and they agreed on building a code editor in a browser. So if you look back, this was 2010. It was not really clear whether something like this is possible, essentially building an IDE in a browser. But it was the project they started with, and they built it for Azure, and they were successful. Probably they have like thousands monthly users, using Monaco on Azure, but that was not big enough for Microsoft. So they were looking around and thinking what to do, and Atom was very popular at the time, and GitHub has created Electron, right, for Atom. And Atom was also written using CSS, JavaScript, HTML, which is the exact tech stack that Monaco had. So they decided to pivot and go to desktop and start to compete with Atom. So they wrapped Monaco in Electron, cleaned it up, open sourced it, and that's how VS Code was born. But they had one problem there. Well, they had a few problems there, because Atom was already quite popular and it had support for many languages, and they didn't. So they came up with the language server protocol and debugger adapter protocol to convince the language communities to build language servers that would work with VS Code and potentially other editors. So today, our language server, for example, runs in Vim. We don't see a reason why it wouldn't run in Emacs probably. Eclipse has a language server client as well. We're now looking at supporting IntelliJ as well. They are lukewarm in adding support for LSP, but we're working on that. So yeah, so that's how VS Code kind of started. And there is a nice presentation about this from JSConf US. You can't probably see it here. JSConf US in 2013, when Eric Gama came there. He called it Massive.js, which I thought was a name of a framework or something, but it took me a while to parse it. He meant that the amount of JavaScript they wrote for Monaco was massive, and he was talking about their journey and how they switched to TypeScript and how that kind of saved them and helped them a lot. So that's a really nice presentation. And he also shows the team that left IBM with him. So these were originally Eclipse developers that left IBM, started working in JavaScript, created Monaco and VS Code. I have a personal story related to this, because VS Code was open source in April 2015, and I switched from mainframe assembler to front-end development, around that time, a year earlier, And I was looking around to learn something about JavaScript. I went to a conference in Ireland at the end of 2016, and I was walking to the keynote in the morning, and there was a guy who stopped me, and I recognized him from the day before. He was Brian Tarleton from Microsoft, a representative to the TC39, the JavaScript Standardization Committee. You know, he stopped me and asked me, you know, are you a developer? I said, yes. Have you heard about VS Code? Yeah, I've heard. Have you tried it? Yeah, so what do you think? Well, okay, it's okay. So, well, we've got a team of developers in Zurich, and we're looking for stuff into their backlog. Like, what do you want? and he opened his leather notebook, like not a computer, like his leather notebook. When he took his pen, it was like that. What do you want? I said, well, you know, I'm a VI guy, and the VI support kind of sucks. So maybe you could make it better. And lo and behold, half a year later, the VI mode in VS Code got pretty good. So it was kind of, you know, my experience with these guys. And so I've got one more slide in here. So at the 10-year anniversary, they did a keynote with Eric Gama at the VS Code Day, and he's recapping the story and how successful they were. That, you know, a lot of things technologically came together to help them. TypeScript on one side, browser engines becoming really powerful on the other side. That a lot of things got together that made VS Code possible. And you know, they said that enable coding in the browser. That was their mission. And in 2020, they got there partially. So they introduced GitHub code spaces, where you know the UI is running in your browser, not in a Chromium that you have as part of Electron, but in your browser. And the extension host that I was showing you runs as a container in cloud, right? So this was 2020, and the VS Code Day was beginning of 2021. But at the end of 2021, they announced VS Code.dev, and they said this is the realization of our dream of making a coding editor in a browser. So I'll show you what. Have you tried VS Code.dev before? Okay, a few people have. All right. So let's take a look. VS Code.dev. You know, there is the blog post. Just look it up on the blog if you're interested, where they talk about it. And I'll need to make this a little bigger. And you can see our familiar assembler application. And still colored, still can scroll. You know, can hover over instructions. And I'm getting the information. I can go to definition. You know the drill already. I can right click. I can pick references. You know, I can start typing. I get the content assist. And we see status. Okay. If I make a typo, you know, I get a complaint from the language server. So this is all a static web application. It's served from Microsoft servers, including the language server. So let me show what it looks like. Show you what it looks like. Alright, tools, developer tools. So I'll close this. You cannot see, but I'm filtering on HLASM, which is, you know, the name of the asset here on the networking panel. And I'll make it bigger like this. And when I refresh the window, okay, I got this thing open. I want to close it because I don't want to see all of those things. No, go away. One more try. Interesting. Let's go. Oh, I see why. Okay, click here, and I'll do a refresh. Okay, so you see, we're loading the extension JS, you know, the main part of the VS Code extension. We're learning a WebAssembly module. We're loading the web worker entry point and language server entry point itself. So this is all served as a static application, all running inside of my browser, no container behind the scenes, everything running in the browser. So, any questions?
Also, you have to check WebAssembly file beside the MJS file.
Yes.
So that's just for browser backward compatibility, or is it essential?
That's a good question. I think that's a segue to what I want to talk about. What I want to talk about next. Let me see. You know, I'm not good with my notes. I think we can talk about this now. so far I haven't told you how the language server is implemented. Like what language it is implemented in. Right. So any guesses? Any guesses? Go ahead.
TypeScript?
No. If it was in TypeScript, we wouldn't need WebAssembly.
So it would be in C, C++,
Rust,
Swift.
C++, and
Assembly script.
not assembly script. It's C++. So you saw it's a multi-threaded C++ application. You know, it's quite complex. And you saw me showing you the language server running in the extension host, and it was a native binary. So so maybe that's a good segue to go back and take a look at it. So if you open extension folder. So in my extension folder, I have my extension here. If I drag it somewhere down here, get VS Code. So this is the unpacked extension as it resides after install it, and the extension manifest is PragueJS. So it's got the standard attributes, name, description, version, license, whatnot. Down here is the main entry point. So this is the entry point for the extension when it's running on a desktop. It gets loaded in a Node.js process. You know, that's what we saw in there. Then for a browser, if you want to make the extension available in the browser, there is a different entry point, surprisingly called browser in here. And so there is this code here, and that's the extension, and from this extension the language server gets started. So if I search for language server, you see that we are starting a binary from the bin folder, and we are providing native binaries for Intel, for Darwin, for Linux, for Windows, and the WebAssembly module that the WebAssembly implementation that you saw. So for browser, we're compiling it with mscripten, which is probably the most mature compiler for C++. There's also WASI SDK, but that doesn't support C++ exceptions and has only experimental support for threads at the moment. So we're using mscripten, and so I'm on Mac OS. So even though this is an Intel binary, Rosetta takes care of it for me. So it runs. But if I was on Linux, what would I do? So let me show you another thing that will kind of bring all of these things together. And let me do it this way. So I have a container running here on my machine. I'll connect to it using the SSH remote support in VS Code. I'll close this. I'll close that. Save. So again, here I have my assembler code. Hover, go to definition, yada yada yada. Everything works. But when I look at the processes, you will see that there is like different extension hosts. There is a local extension host that runs UI stuff, UI related extensions, and there is a remote extension host running inside of the container. And was there a question? No, okay. And here is my language server. So if I right click on it and do a copy, and I now go back and open, create a new file over here. TXT. I paste it in and I'll be patient and I'll scroll around. So it starts Node.js, and inside Node.js it starts the language server from the WASM folder. So we're using the same WebAssembly file that we run inside of a browser to support the desktop platforms for which we do not provide native binaries. So that's a power of WebAssembly, which was kind of a promise of Java. You write it once and it runs everywhere, but it's really not the case because it doesn't run in the browser. So with C++, we can see that write once, compile everywhere actually works, and maybe with WebAssembly, we'll have write once and run everywhere for real. So, any questions? Yes, Pavel.
Why did you choose this way? Because definitely when you do some extension for VS Code, you will use JavaScript, TypeScript. It's not necessary to write it in C++ and compile for different platforms. So what is behind this decision? Performance issues or something like that?
Yeah, I mean, there is a lot of performance optimizations. I mean, the parser, the language itself is strange. We are using an Antler-generated parser with a lot of other tricks around it. So, I wasn't there when the project started, but I think we would not be able to accomplish what we have today if we try to use it just write it in TypeScript. So we've been going through series of performance optimizations over the last year or two, and we are almost as fast as the native compiler now. And so yeah, we used to have cases where our parser crashed a lot. Then we identified those, fixed those. Then we had times when parsing took like minutes, and now we are at like 8 seconds for majority of the things. For reasonably sized modules could be 2 seconds. So, yeah, there is a lot of performance optimizations in there, and we actually had this ready quite a while ago. And that's not this one, not this one. How am I with time?
So we're half an hour already.
Okay, so I'll be quick now.
Yeah.
So we actually had the POC done in November 2 years ago, and but in order for it to work, we had to disable security in Chromium to get around a problem with shared array buffer that required cross-origin enablement. It took Microsoft about a half a year to kind of provide some fix. They enabled it first on insiders.vscode.dev, and you had to use the VS Code COI query parameter to get this working. And then they put it also to vscode.dev, and as of, where is that? Let me refresh this page. As of September, it's turned on by default on vscode.dev. So it's a relatively new thing on vscode.dev. And the VS Code team has actually done something similar, kind of funny. They on their blog, if you look at like 2 blogs back, they created a nice blog post to run web assemblies in VS Code for the web. So what they did, they compiled a Python interpreter into WebAssembly. They wrote a small shell in TypeScript, they compile the core utils, essentially a rewrite of core utils into Rust that somebody did. They compile it to WebAssembly, and they included all of this together. And then they had, then you could open a repo with Python and run it in your browser. And it felt like you're working on a real machine, but it was all happening in your browser. And they talk about how they did it. They actually used Vase SDK. They didn't use Mscripton because they had some reasons for that. Yeah. So there's a lot of cool things happening around WebAssembly. And I just wanted to share what we did here. And speaking of WebAssembly, the main language that often gets talked about is Rust, because the team has made a lot of effort to support WebAssembly as a first class language. Mscripton obviously made C++ work really well, which we just showed you that it really works. For languages that require garbage collector, that was kind of a problem. So Go shipped their own garbage collector. We're also using it in one of our projects internally so far, but that means that the binary is several megabytes big, because of the garbage collector and the libraries it includes. So it's no good. But recently, October 31, WebAssembly garbage collection was enabled in Chrome, and it's coming in Firefox. It's in the nightly builds, so it will soon come in Firefox. So we can look at this space and see, hopefully, garbage collecting languages, being soon available in browser through WebAssembly. So if you'd like to learn something, there is a Vase.io conference, the early bird tickets, and December 17th. So I think it's time for us to look back at the old saying that always bet on JavaScript and update it. Always bet on JavaScript and WebAssembly. So thank you.